Table 2. Someone tell me something you noticed from these tables.
The first one, the higher the input is, the input is, and the yellow is the next one.
Okay, so in the first one, we're noticing that as the x's increase, the y's, you said, do what?
Decrease.
And is that consistent throughout? Okay, yes, it might not look like it, but they actually have one of the inputs out of order. If we put it in order from least to greatest, now you can really see like it's decreasing. And then for the other one, a notice was that we do have an exponent. 3 is in the exponent spot, and it's like the top right corner. Table 3, give me another notice. Okay, so going from negative to positive. Table 4, give me another notice. They're both functions, and how do you know if something's a function or not? Okay, good. So when I look at both tables, we can say that they're functions because the x does not repeat. And in both situations, they show you what they are doing. I don't know if anyone noticed that, but they are showing you what they're doing to go from the input to the output. And they're using, what do we call it when it's in this format? F of x. Function notation. Good. So function notation, we learned that yesterday. F of x equals y. So instead of it being x and y columns, they use x and f of x, which is f of x equals y. So yeah. And they're showing you what they did. So in each row, for the first table, they are applying this expression. So if we use function notation the way that it's meant, if this is x, then I should be able to plug this in anywhere that x is. Loading, let me let it catch up for a second after what's happening. Okay, hang on. Okay, so 10 minus 2 times x, which for the first input is 1. All right, now do your order of operations. Do we subtract first or do we multiply first? Multiply first, so 10 does, yes, you multiply first. What's negative 2 times 1? And then bring down that 10. What's 10 minus 2? So in function notation, we got our input, we got our output, and that's what it's showing in the table. And feel free to check it yourself. Anytime you plug in x into this, you get what they have as the output. And same for this one. If I were to plug it into the other table, the g of x, my first x is negative 2. And anytime you plug stuff in, always use parentheses. And you could put this in your calculator, but what it is negative 2 times itself 3 times. That's what exponents tell you to do. You multiply the base by itself that many times. What's negative 2 times negative 2? I'm sure it's negative 4. A positive 4, and then times the negative 2 is, and that's what it says in the table. And then the rest of them are a little easier since it's not negative. 0 cubed is 0. 1 cubed is 1. 3 cubed is 7, and so on. Okay, so good. We could tackle the wonders, but kind of have a jam-packed day today. So we'll go from there. Any questions at all on that warm-up? All right. And if you notice, according to this on the board over here, we should be on lesson 3, but because I have to have a sub tomorrow the first hour only, I need a recording for them to watch. So that's why we are kind of going ahead a little bit. And then tomorrow we'll do lesson 3. Okay, so this is just for my first hour. They're recording. But moving on. So now we are on to what's on your paper. You have 4 functions. They're all equations. You're going to match them to one of these verbal descriptions that represents one of the functions. So start with just the matching. I'll give you about 2 minutes based on the verbal descriptions, which function is each. And if you finish that early, move on to these other 4. So table 4, can you tell me one of the matches you made?
The first one was C.
Okay, so we're saying the first one goes with C. Anyone disagree with that? All right, so to get the output, you multiply the input by 3, then subtract 7 from the result. So yeah, according to our order of operations, you would have to multiply before you subtract. So the way that this is written looks good to me. Table 5, what about for g of x? Which one would you match? Or, yeah, I'll assign you. G of x goes with b. All right, so let's see. To get the output, subtract 7 from the input, then multiply the result by 3. So because these have the parentheses in there, that moves the subtracting in step 1, because you always do what's inside the parentheses first. So I would agree that's a good match. Table 1, which one would go with the h of x? D. So let's see. To get the output, divide the input, which is x, by 3, and then subtract 7 from the result. So I agree with that one. Because you would normally do any dividing before you subtract. So then by process of elimination, that means k of x goes with a. And that one says to get the output, subtract 7 from the input, so from the x, then divide by 3. And this one is a common one that people know that the fraction mark needs to divide, so they think they need to divide by 3 first. But truly, you need to work out the entire numerator and denominator before you then divide. So good practice on that. Now, for one of the functions, when the input is 6, the output is -3. So inputs go where for function notation? In place of the x. So what you should have done for this one, and you might not have gotten to it yet, so let's just kind of get to it now. What you should have done for this one is plug in 6 into all of them until you find the one that, when you do that, you get an output of -3. Does anyone think they know which one, Jude? Okay, so let's try that. If my input is 6, that means it needs to go anywhere that the x goes in the equation. So whenever you plug stuff in, use parentheses. I know sometimes it doesn't make a difference. And really, this whole part on the right side, you can put in your calculator and make your life a little easier. It'll do the order of operations for you. But they're not too bad. We can do them by hand right now. So parentheses first with 6 minus 7. And 3 times -1 is, so yes, g of x is the correct function to answer that. All right, everyone with me so far? I know we kind of went through that one a little fast, but that's the gist. If I were to plug in 6 into any of the others, I would not get -3. Like if I plugged it into f of x, 6 times 3 is 18. 18 minus 7 is 11. So like it wouldn't be f of x. So you go through until you find your answer. All right, so then the next one. Which function value f of x, g of x, h of x, or k of x is the greatest when the input is 0? And then what about when the input is 10? So that one I'm going to give you some time to work out because you would have to compare all of them when the input is 0 and when the input is 10. So I'll give you 4 minutes. I'll see where you're at in 4 minutes. Consider dividing and conquering within your groups if you like. Or just do them on yourself. But I'll give you 4 minutes to start. So free to use a calculator. I apologize that there's not really room to put all of your scratch work. If you want to add it to like a separate paper and add it to your notes, by all means. But if I'm trying to determine which one would have the greatest output when the input is 0 and then when the input is 10, inputs are your x or y of a function. So that means first, when I'm testing out for the 0, anywhere that there's an x, I need to replace with first the 0 and then see what I get. So the left side is just notation. All right, it's just saying when I plug in 0 to function f, you don't have to do anything to this side. Because it's not f times 0 or anything, just leave it alone. On the right side, you can put that whole thing in your calculator if you want. But I know I multiplied before I subtract, so it's 3 times 0 and 0 minus 7. Okay, good. And then I still have to figure it out for G, H, and K. Plugging it in. Then 0 is my input. Anywhere that there's an X, I need to replace with the 0. And the math might be slightly different, but you can use your calculator for it. Okay? So now when the input's 10, so I'm just getting you started here. For f of x, my input is now 10, so I'm going to replace all the x's with a 10. And then simplify. So on the right side, you can put that whole thing in decimals if you want. But what's 3 times 10? And what's 30 minus 7? And then now I have to compare that to when I plug 10 in for the input and all of the others. Does that make sense? So now for like G of 10, on the right side, you do the parentheses before multiplying. What's 10 minus 7? And then what's 3 times 3? 9. So far, I know in this one, when we were testing when the input is 10, I know that I'm not going to pick G of x because so far f of x is greater than G of x. I still need to test h of x and k of x. Does that make a bit more sense? Okay, do that now. For the rest, if you haven't come to an answer yet. If you already did, great. Read ahead to the next activity. But we're testing all of these. So we did some of them by hand. Let's also use a calculator too. For when the input is 0, what did you guys say? Like which function is the greatest when the input is 0? F of x, g of x, h of x, or k of x. Okay, so let's see if you're right. I still need to find the answers for G, H, and K when the input's 0, but we'll just see if you're right. Okay, so for the first one, this was what we would have plugged into our calculator if we used it. G of x, when the input's 0, we get -21 for that one. So G of 0 is -21. Now for h of x, so how do you make the fraction in Desmos? Press the slash or the division sign. because a fraction bar means to divide. So if you press that, then you get this, and you can just type in my input that we're testing right now is 0. We're going to divide that by 3 and then arrow out of it. And then it's -7. This is your h of x, right? And when I do that, I get -7. So h of 0 equals -7. Now k of x. Question so far, are we good? So that one's also in like a fraction form. I'm going to press a slash. On the top of my fraction, it's going to be 0 minus 7. And denominator's 3. And that's about -2.3 repeating. So k of 0 is -2.3 repeating. Now, here's all my values for when the input's 0. Maybe let me highlight them so you can see them better. Which value of the output is the greatest out of these 4? So that is why k of x is greater out of all of these ones. Questions on that? All right, so then now we just have a few more to test for when the input's 10. We already found these 2 by hand. Now we just got to do the other ones. And since I already have it in my calculator, I just have to now change the input. So instead of 0, the input's now 10. In h of x, that is -3.6 repeating. And in k of x, or not k of x, I should say k of 10, it's 1. Okay, so now compare all the functions when the input is 10. Which one is the greatest out of all these numbers? The f of x function. So f of 10 is greatest out of that list. Okay, so questions on that. If you're using a handheld calculator, I would just recommend, like, whenever you put fractions in the calculator, use parentheses. But yeah, it's good on this activity. Okay, so now on to the next activity. We are going to talk about perimeter and area for a second, just because those will often come up, especially on your state testing. And I'm not a huge fan of them because if you don't know perimeter or area, but you maybe know the other skill involved, then you're like inhibited from answering it right. So let's review. A square that has a side length of 9 centimeters has an area of 81 centimeters squared. The relationship between the side length and the area of a square is also a function. Complete the table with the area for each given side length, and then write the rule for function A that gives the area of the square in centimeters squared, when the side length is s centimeters, and use function notation. So they did give you this one. When it's 9 centimeters, my area is 81 centimeters squared. What do we know about squares? All the sides are the same. So then if one side length is 9, that means all the side lengths are 9. How are they going from 9 to 81? What math are they doing? 9 times 9. So now you guys fill in, based on what we know, the area when the side length is 1, when the side length is 2, when the side length is 4, and then eventually when the side length is s, what would my area be? All right, do that. Table 3, when the side length of a square is 1, what's my area? Okay, 1 centimeter square. And then table 4, when my side length is 2, what's my area? Yes. Like adding that. Table 5, when my side length is 4, what's my area? 16. Table 1, when my side length is 6, what's my area? 36. And table 2, when my side length is S, what's my area? S squared. You could have also written S times S. They practically mean the same thing because the exponent tells you to multiply the base by itself that many times. And that's what we did in each situation, in case you're confused. We took the input, times it by itself, or in other words, squared it, and that's how we got the area. Now, for this part, to write the rule for function A, so that means that's my name of the function. Use function notation to show for any input of S, this is what you do. Okay, that sounds confusing, but it's really not. Function notation. Listen. Full attention. Function notation, we always start out with the name of the function, so they want us to use A. We're calling it function A. In parentheses should be the what of a function goes in the parentheses. The input, what's my input? Using variables. S. And then what do we have to do to the S to get the output? So then my output is going to be S squared. Now for any input of S, I can get the output. So this is what we mean when we say write a rule. Basically write it in function notation. You have your input there and what you're doing to your input to get the output over there. Then, any questions? So don't overanalyze that too much. I know like we'll see a variable and panic, but it's just what you were doing with the numbers, except for now it can be any number when it's a variable. Questions, comments, concerns? So then what does A of 2 represent? So when the input is 2, and what does that mean in this relationship, like in this situation? So when the side length of a square is 2 centimeters. All right, that's what A of 2 is representing. Do we know the value of A of 2? Yeah, it would be 4. So A of 2 equals 4. And now it would be when the side length of the square is 2, the area is 4. That make sense? Okay. I'm going to skip the graphing. I mean, hopefully you know how to graph. All of these are coordinates. But I think you guys get the picture. 1, 1 would be probably somewhere here. 2, 4 probably somewhere here. And so on. Yeah. Anyway, let's get to, because I have a Kahoot ready, but I don't know if we'll get to it. We'll see. On the back side, as much as I love word problems, I'm kind of over them a little bit. So let's not do that word problem. Let's look at this. Okay, so kind of making it a bit more straightforward. Function B is defined by this equation. This time, you're allowed to use graphing technology. Otherwise, you just got to do it by hand. So we did it algebraically earlier in class. If you'd like to use graphing technology, we showed you how to use graphs that were already given to you to find the inputs and outputs. But I'll show you both when we go over that. So look at this part of your paper that's on the back and have answers for both parts. So in this one, we're asking you for the output. In this one, we're asking you what's the input when the output is set. Okay, it's 6 things, so I'll give you 6 minutes and we're definitely going over it. But the sooner you get done, you might get to do something. So we'll do. Okay, I want to do the Kahoot, so let's kind of get started. Even if you're not done yet, I think it's easy enough to figure out how to go. So in number 1, are they providing you the input or the output? They're providing you the input, and you know because in function notation, X is the input, it's always in the parentheses. So that means you got to take function B, which is this. They always will provide you either a graph, an equation, a table, and based on function notation is replacing where the X normally goes. So everywhere that there's an X in that given equation, you replace with what the input is. Does that make sense? Mm-hmm. And do I have to do anything to the left side? Is that B times 6 on the left? No, it's just function notation. Is this telling me I input 6 into function V? On the right side, we can simplify that by using Desmos or just know your order of operations. What's 10 times 6? And 60 plus 25 is... And this way, I can clearly see my input, and I can clearly see my output. My output is 85. Good on that one. Okay. I'll show you with the graphing calculator on these two, so don't you worry. Now, let's look at number 2. What are they providing me, the input or the output? On number 2. They're giving me the outputs. And I know that they're giving me the outputs in each of them because X is still X. All right, the one that got replaced with a number is your Y, the output is what Y is. So in that case, I need to replace, since 93 is what B of X equals, and let me even copy it down here so that you can get the full effect. If a B of X equals 93, I need to replace the entire B of X with 93. And then that's going to equal 10x plus 25. And now we're solving for X. Questions on that? All right, let's see who remembers. When we solve for X, we start with what's farther. Do I need to get rid of the 10 or the 25 first? How do I cancel it? Good. What's 93 minus 25? It's 8 is what it is. Equal to 10x. What's the opposite of multiplying 10? And that equals 6.8 for the first one. And this one, X equals 6.8. Questions on that one? Okay. I said I'd show you with graphing technology, so I will briefly. So to use your graphing technology, you got to know what the equation is. And the equation's right here. I'm going to open up Desmos, and I'm going to type in the equation exactly how it's given to me. So it's B of X equals 10x plus 25. And look, we get a graph. Now we know how to read graphs on paper, but when it's Desmos, you can click on the line and see, for example, when my input is 2.75, just kind of hang on to it until you get to the part where it's 2.75. So here's 2.46. I got to keep holding. Okay, you see that? Because if I let go, it's going to go away. So at 2.75, what's my output? All right, everyone listening, everyone look at the screen. When my input is 2.75, what's my output? 52.5. So, 52.5 when my input is 2.75. When my output is 42.1, so my output is usually X or Y. My output is usually Y. So that means when I'm touching on my line, I need to pay more attention to the Y's now. When the Y is 42.1, okay, almost there. Let's see if I can do it. Okay, I might have to zoom in a bit more. Okay, but 42.1, you see it? I got it. What's that X value going to be? 1.71. So that's another way. So B of 1.71 is 42.1. Or you can just know how to do the math of it. So good, any questions? Okay, we might have to save the Kahoot for tomorrow because by the time everyone gets into the Kahoot, it'll be like time to go, I feel like. So we'll leave it at that. Luckily tomorrow's lesson is short, so we'll probably have time for the Kahoot tomorrow, but that concludes our notes. Use the remaining time to start your practice. There's actually 2 for this lesson, but they're both really short. So knock out a few questions while you're in here.